Now let us discuss about binary search in an array. So we are given a sorted array. Please remember the approach we are going to discuss will work only in a sorted array. So we have the values like 1, 3, 6, 8, 10, 15, 30 and then 100. So now we are given a new value, something like 12. So what is the index at which 12 must be inserted, so that the array remains sorted? That is the question. So by looking at that, we know it has to be inserted between 10 and 15. That is, in the index of 15 it should be inserted and all these things should be shifted right. So let us write down the index values 0, 1, 2, 3, 4, 5, 6, 7. So the binary search function must give 5 as the answer. So in place of 15, 12 must be inserted and the other things must be shifted. So now how are we going to do this? So we will have two variables. Left will be initialized to the first index, which is 0. Then you will have right. Right will be initialized to the size. So what is the size of the array here? It is 8. So right will be 8. Even though the index 8 is not there, we will be initializing right to the size of the array. 8 elements are there, so right is equal to 8. So now midpoint we have to find. So midpoint will be right plus left by 2 or left plus right by 2. So what is it? 0 plus 8, 8 by 2, which is 4, index 4. So now let's say this is the target element, because this element must be inserted into this, So now you are going to compare the value at index 4. What is it? 10. So you are comparing 12 and 10. So if 12 is greater, if 12 is greater, what are you going to do? You know that 12 must be inserted in the second half. Now you are having first half which is from 0 to 4 and second half which is from 4 to 7. Now 12 is greater than 10, which means it should come in the second half. So second half, if it has to come, left will be pointing to mid plus 1. It will be pointing to mid plus 1. So you are going to check if target greater than mid. That is, the target is greater than the value at mid index. Mid index. Then it has to be in the second half. That is right half. So because it is going to be in the right half, you are going to change this left to mid plus 1. So left will become 5. So now again you are going to recalculate. Mid is equal to left plus right by 2. 5 plus 8 by 2. 13 by 2. So it will become 6. Because it will not be 6.5. It is integer arithmetic. So 13 by 2 will be 6. Now what is the value at 6? It is 30. So you are going to compare 12 and 30. So is target greater than the value at mid index? Mid index is 6. No. Target is less than or equal to. In this case, you are going to say right is equal to mid. You are going to say right is equal to mid. So you will be initializing this right with 6. That is, you will be updating the value with 6 because mid is 6 now. Fine. Now again you have to recalculate. Mid is equal to left plus right, 11 by 2, which is nothing but 5. So what is the value at index 5? It is 15. So it is 15. So we will write down 15. Is the value greater? Target is greater? No, target is smaller. So what we need to do is we have to update right with mid. So it will be 5. So this process you need to continue as long as left is less than right. Left is less than right. Because if both are equal, then that is the location at which the target must be inserted. So now, because left is equal to right, you can return the same value. You can return left or right because both will be same. So you are going to return 5, indicating that this 12 must be inserted here and the 15, 30, 100 should be shifted right. So now let us look at one more example. So we have the array 1, 10, 22, 35, 40, 44, 52, 60 and then 100. So the target value, okay, whatever we have to insert is 200. So let us write down the index value 0, 1, 2, 3, 4, 5, 6, 7, 8. So now let us write down the left index. Left is equal to 0. Right is nothing but the size. So 9 elements are there. So size is 9. Mid is equal to left plus right by 2. So which is 9 by 2. So you will get 4. So now you are going to compare 200 with mid value 40. So you are comparing 40 and 200. 200 is greater. So it has to be in the right half. So because it has to be in the right half, left will be equal to 5. Now again you are recalculating. 5, how did we get? Mid plus 1. Okay, mid plus 1. 4 plus 1, 5. So now you are going to recalculate 9 plus 5 by 2, which is 14 by 2. Mid is equal to 7. So now, what is the value at index 7? It is 60. You are comparing. Still 200 is greater. So left is equal to mid plus 1, which is 8. So 9 plus 8, which is 17 by 2. Mid will become 8. It will be 8.5, but in integer arithmetic, it will be 8. Now, what is the value at 8? It is 100. Still, 200 is greater. So, left is equal to mid plus 1. It will become 9. As I said, we need to continue the logic as long as left is less than right. So, now, left and right are equal. So, we have to return the index 9 as the answer. So, 200 must be inserted in the end, creating an index 9, and 200 must be inserted. So this is how we proceed with the binary search. So let us write the code for that and test out 2 example input-output. So now let us accept n, which represents the integer values. So we are going to accept the value. We'll declare an array. We'll accept the input values in a loop for int index is equal to 0, index less than n, index plus plus. Okay. Fine. So now you have to accept the input value, which we will call target. Okay. So you will use the scanf to obtain the input value for the target. So now you need to return the index at which the target must be inserted. So the array is sorted. Okay, please keep that in mind. So now we are going to say printf. We are going to invoke a function called binary search. So we are going to pass n, array, okay, and the target value, all these things. So because this will be returning the index, it is an integer, so %d, and it will be printing that. So we'll be saying return 0. So now let us complete the binary search function. So let us do it here. Int binary search. So first argument is int n, and then int array of n, then int target. So first int left is equal to 0, right will be the size of the array, which is nothing but n. So now you will be calculating midpoint. Okay, midpoint you will be calculating. But let us do that inside the loop. While left is less than right. Okay, while left is less than right, int midpoint is equal to left plus right by 2. So if array of mid, okay, or we will say target is greater than array of mid, then left is equal to mid plus 1. Else if it is less than or equal, okay, if it is less than or equal, then it means it is in the first half, that is left half. So right, okay, right equal to mid, because it can be less than or equal also. Okay, so we cannot say mid minus 1, we have to say mid. So now when this condition fails ultimately, so this will be repeatedly calculated. When this condition fails, this will come out of the loop when left is equal to right. So at that time you can either say return left or right, because both will be same. So now let us execute the program. So we are going to give some 9 input values: 2, 4, 55, 60, 70, 88, 100. We have given 7 values: 200, 555. Okay, 3, 3, 6, 7, 8, 9. Now you are going to give a value like 99. So it is returning the index value 6, because 99 should be inserted in the place of 100 and it should be moved. So what is the index value? 0, 1, 2, 3, 4, 5, 6, which is perfect. So let us give one more example. Let us give 4 values: 10, 20, 30, 40, and we are going to give a value like 5. So it is giving 0, because 5 has to be inserted in the first position. First position means index is 0. Let us give one more example. So 4 values: 20, 55, 70, 80. So we are going to give a value like 500 or 5000. Okay. So it is giving 4, because 0, 1, 2, 3. After that only 5000 comes. So the index value is 4. So please understand the program and solve it on your own. Thanks a lot for watching.